Welcome back, my dear students. The last class we have seen the error detection, error correction mechanisms, right? In that we have seen what is that a single bit error and then multiple multiple bit error and then burst error. Okay, and in this class we are going to see about some detection techniques and then how to correct that information, right? These are the things we are going to see here. Okay, let me move on to that slide and then we will discuss. Right. So as I told you that burst error, you see here, they are given one definitions like means that two or more consecutive bits in the data unit have changed. Okay. So if any two bits got affected, then we can say that it is the multi-bit error, multiple bit error. And if it is more than two, then we can say that it is that burst error. Okay. Burst means the bunch, the group. So that what they are given is you see this example diagram also. So nearly the three bits got changed. That's why they are telling it is a burst error. And the deduction methods. So this is the important concept. You see here what are the deduction methods we are having. The parity check, cyclic redundancy check, and then checksum. Okay, so these are the three methods we are having to detect some errors. Okay, I think already we had discussed that checksums in that last class itself, because you see I told we had to add all the values of the checksum header, then we need to take that one's complement of the sum value. Okay, so whatever that value we are getting for that one's complement, that will be the checksum. This we have discussed in the previous classes. So we will discuss about the parity check and then cyclic redundancy check now. Right. So you see this diagram and the difference is the parity check. So the parity check, parity bit is added to every data unit so that the total number of ones becomes even for even parity and or for odd parity. Okay. So what they are telling, we are transferring some data to some destination or the target places. Okay, so I told you that data will be converted into the binary only, and directly we cannot transfer all the binary data to the target machine, so we have to make a group. So while receiving that binary information, it will make the group for example 7 bit or the 8 bit like that. Okay, so in that group we need to find out how many ones are present. Okay, so if you are going for the concept of even parity, then you have to find out how many ones present in that received data. If it is a even number, then we can say that okay, that received packet will be good only. Okay, because there is no odd number of ones. There are no modifications. If any hackers are include one or any zero, means the count will be getting different. Okay, so we are looking for that count only. And if you're looking for the add parity check concepts, then the received information should be in that odd numbers only. So that if you are receiving any even numbers, then we can say that some of the modifications has been done in that. Okay, so you see here I have given one example for understanding this even parity and then odd parity concepts. Suppose the sender wants to send the word world. Okay, in ASCII the five characters are coded as, that means the WORLD. So all these five letters, all characters are converted into the binary values from the ASCII value. Okay, first they are taking the ASCII value for each and every character, then from the ASCII value they are converting into the binary. Okay, now you see each and every place we have to count the numbers, number of ones. Okay, in the first letter W, you see here, totally we are having the six ones and then one zero. So we are not going to look the zero counts, only one number, right? So here we are having that even number of ones, so it is that even parity only. So already it is there, even number of one is there, so we are not going to modify anything in it. So simply we have to give one component to the zero only, because zero is the odd number, so we are just giving one company zero. That's it. So zero zero, so two zeros we are adding with that. We just see that value in the below also. Okay, and the next number is the character is O. So for O we are having again, you see the six number of ones and then one zero we are having. So this is also even parity. So exactly we are having the six numbers of ones. So there is no modifications needed here. So simply we have to add zero only. And The next character is R. So in this R you see here, we are having four ones and then three zeros. So totally it is, it is a even parity because already we are having that four ones. So okay, it's good because there is no odd number of characters here. That means odd number of ones here. We are using that even parity function, so we should look for the even number of ones only. Okay, if we are having the odd number of ones, then we need to make it to the even. That's it. This is the concept we have to go for. And the next one again, the L. For L we are having 110 1100. So here also we are having the even number of ones and then odd number of zeros. So that is we have to add only the 0 extra. Okay, but in the final letter D, you see here we are having triple one and then four zeros. That means now the number of ones in the odd counting. Okay, so you see here, if we are having the odd number of ones, then we have to make it even number, right? So what we have to do, simply we have to add one more bit 1, okay, in this characters. Okay, so now if you are adding this, then automatically this number of ones count will become even. Okay, so we have to share this information only. Okay, so after making it to the even parity, then we have to share this information to that opposite party. Okay, in that opposite side, they will resolve this information with the help of the even parity. So they will find out these characters and then finally um, they will find out, okay, what are the characters are there, and then based on that ASCII value, binary values, they will convert into the ASCII, and based on that ASCII they will find out the characters. Okay, but in sometimes what will happen, few problems, little problems we have to face in this kind of things. So because what will happen directly, you see here we are just passing the 7-bit value, right? uh, yeah, 7-bit value. On the receiver side we are sending 8-bit values. Okay, the original information is the 7-bit, and that receiver side it is in the 8-bit. So simply they are removing that 8-bit only. Okay, so there is okay, no issues in this. And then two-dimensional parity check. So you see here, in that even parity odd parity method, we are simply taking one character and then the corresponding binary values. But here we have to take multiple characters at the same time. Okay, so in this place we have to look for the column and then row wise parity values. Okay, you see here, first they are taking one value and then they are keeping in that top. Okay, 11001 triple one, and then 101101, and then 011101, again 01010001. Okay, so that numbers is the original data. They are arranging in one by one like a matrix format. Okay, so here what they are doing, column is also they are checking for that even parity value or unparity value. The same way, row is also they are checking for even and then odd parity. Okay, whatever that parity check method you are going to use, that only we have to follow. Okay, if you are following that even parity, then you have to look for the even parity in the column and then row wise. Okay, otherwise you have to go with that odd parity. There is no issue. So you see here what they are filling. So the we will go for the first row. So 1100 111. So you see here totally 5 ones we are having and the 2 zeros we are having. So they are adding one. So it means that they are following that even parity value. Okay, because they are making that odd number of ones into the even number. So indirectly we can understand that okay, it is a even parity. And if you are looking for the column 1100, so you see it is that even number only, so simply they are adding 0. So they are in this place you have to see, now we are having odd number of zeros. Okay, but it doesn't mean that okay, we are following that odd number of odd parity, because we have to look for only one bit value. Okay, that means a bit value 1. Okay, so likewise for each and every column and then every row we have to find out that odd number of ones, and then if we are having any odd number of ones, then we need to make it a even number. That's it. and then finally we have to attach these two values. That means we got that parity value, right? That parity value also will be attached with our information. Okay, then that information will be going to that receiver side. In that receiver side they will remove that, last last one bit, and then they will again they will perform the reverse process of getting the original data. So in this way they will verify the data. If anything modified here, then obviously it will affect that odd number and the even number count, right? So that in that moment they will understand, okay, something will happen, so they will modify the data. That's it. And then final concept is that CRC. It is very important one, because here we are going to produce that new checksum value. That means the CRC value. That value is called cyclic redundancy check. So first we have to find out that CRC value. Then we have to add that CRC value with our original data. Okay. So along with that CRC only, that data will be forwarding to the destination machine. That means the receiver side. So the receiver will remove the CRC, again he will get the data. Okay, and how they will understand that, okay, received information is right means, now we are forwarding this data with the CRC, right? So in this method we are following binary division operations. Okay, so first we are doing the binary division operations with some concepts. There is some steps are there that I will tell you. So we are getting some values as output, that means the result. So that result will be the CRC bit. Again we are adding that bit with our data, and then we are sending to the receiver. So in the receiver, again they are doing the CRC, binary division. Okay, if you're doing that binary division, they will get all the terms or zeros as a result. Okay, if all the terms are zero, then it is good message. That means there is no modification, so that message will be accepted. Okay, if any terms are giving one instead of zero, means that time that message will be rejected. So this is the concept they are keeping. And you see here in that right side diagram, the center side, they are using first data. After that they are using some zeros. Okay, they are telling n bit values. Okay, and these are all going under that division operations. There we are using divisor with n plus 1 bits. Okay, so first along with the data we have to add some n number of zeros, right? So how many zeros we need to add with the data means, they are telling that whatever the divisor number we are having, from that length less than 1 we have to add. This is the concept we have to use. Okay, so now we are having the original data, and then one less than the divisor length of zeros. Okay, suppose I am telling 5 digit of divisor I am using. So what I have, how many zeros I need to add with the data means 5 minus 1, because it is divisor is n plus 1, and then that zeros is n bits. Okay, simply 1 less than that n plus 1. Okay, so 4 number of zeros I need to add with the data, like that. Okay, after that I need to do that binary division operations. Then I will get some result, right? Sorry, that result bits will be a CRC bit. Okay, cyclic redundancy check, that will be added with the original data again that data will be forward to that the receiver side. Okay, now what will happen? The receiver receives the data and then CRC, and he also having the same divisor. If you divide that data, he will get the zero as a remainder. Okay, once the data is giving the zero, then it is the good data. Okay, then they will accept, otherwise they will reject this data. That's it. This is the way how they are doing that, error detection and corrections. Right, you see here one example I have given. So first what they are doing, simply 100 is the original data, and 1101 is the divisor. Okay, so the first step is we have to add n number of zeros with our original data. Okay, how many bits we need to add, that we have to find out from the divisor only, because the divisor having that n plus 1, and then n number of zeros is n. Okay, so totally we are having 4 digit in the divisor. So how many zeros we need to add with the original data means 4 minus 1. That means the divisor length minus 1, right? So here the 4 minus 1 gives the 3, so 3 zeros we need to add with the original data. Then we have to perform that binary division. Okay, so if you are doing the binary division, then as a result we are getting that 001 in the last. Okay, so that 001 is that CRC bit value here. So what will happen here, 100 is the original data. Along with that original data we are adding this 001 also. Okay, so this only we are going to pass into our resource array. Okay, right, we will check in the next slide, then you will understand. So you see here, so as I told you that dividend value, you see the original data along with the CRC value will be present, and then again they are using the same divisor. Now they are again doing the binary division. Okay, and you see the result. The final step, as a result we are having the all the terms of 0, right? So it means that whatever the data is transferred to the resource side, that is accepted because all the terms are giving the 0 in the binary division, so it will be accepted. If any one bit value is not 0, it become 1 means simply they will reject, because it's not satisfying the condition. That's it. So at that moment they will understand, okay, something happened, that's why the data is not giving the right value. So in this way they are doing some error corrections and then deduction. That's all about today topic. And if you have any questions or any doubt, please feel free to contact me on the given email ID, and then my number also given here. So anytime you can call me. Thank you.